Does anyone have a question? Anybody? No questions?
सर मिड टर्म का सिलेबस कहाँ तक है?
Everything that we cover before the midterm.
ओके सर। और सर मतलब मिड टर्म के क्वेश्चन पेपर किस फॉर्मेट का होगा? बेसिकली ये जो कोर्स है वो तो प्रैक्टिकल है, तो थ्योरेटिकल कैसे कुछ क्या लिखना होगा, कोई आइडिया थोड़ा सा बता दीजिए।
We have had a take handwritten homework. Remember
ओके,
that?
यस सर, यस सर।
Okay. So
ओके सर।
that is one you can have. There are other possibilities also. As long as you have attended classes and understood what is going on, I think you should be fine and done the
ओके सर,
assignments.
ओके सर।
I'm thinking of giving us a half an hour programming assignment also. No, not assignment, part of the exam.
हाँ,
Okay,
यस सर, यस सर, यस सर, ये बढ़िया रहेगा सर।
so we'll have two parts, the theoretical part as well as the programming part.
यस सर, यस सर।
So if the exam is 1.5 hours, I'm thinking 1 hour or 45 minutes for the handwritten part and 45 minutes for the programming.
ओके
Okay.
सर, ये बेस्ट रहेगा सर।
Okay. That is what I'm thinking. So please do not think that this is final. Anything that is final, I'll send you by email. Okay. This is just what
ओके
I'm
सर,
thinking
ओके सर।
right now. Okay. Anybody else has a question? No questions? Anything from the assignment? If anybody has any clarifications? No clarifications required in the assignment?
सर वो स्ट्रेटेजी जो बोला है उसमें, तो सर स्ट्रेटेजी मतलब मीडियन की जगह मोड और मीन तो कुछ भी ले सकते हैं?
No,
फर्स्ट
so
क्वेश्चन।
how many, so in the imputer function, how many possible strategies do you have? I don't know. I was just made up that question.
आई थिंk 3, मीडियन मोड एंड मीन, आई थिंक।
Yeah, so
Sir, four
that,
are there.
what is the fourth
Four.
one? What is the fourth one?
Was a constant value.
A constant
कॉस्ट
value.
या सर।
So how do you decide that constant value? That is, I don't think constant is a good option to
यस
compare.
सर, यस सर।
Okay, because you finally you have to decide the constant from somewhere. So you can compare the three: median, mode, and mean. Okay, so that is the basic point. And actually the basic point was to make you understand what the imputer does. Okay, but I made it a little more complex so that you that will help you in understanding what it is doing. Okay. Anybody else has a question?
हाँ सर, ये जो 4 पार्ट हैं सर, सब सब के 4 पार्ट्स को सेपरेटली करना है या
What do you
फिर
mean?
मीन्स फर्स्ट पार्ट में स्ट्रेटेजीज का है, सेकंड में ऑर्डिनल एनकोडर का है, तो इनको सेपरेट करना है या फिर एक में ही सबको कंबाइन करना है?
Now you can use the same notebook. You can keep going, or maybe you can do it if
सेपरेटली
some
ज़्यादा
if
बेटर रहेगा सर।
yeah, if something requires that you should have a previously stored value which is getting changed. So maybe you can have some those variables again and again. Maybe because then separately is fine. But how are you going to upload that on?
जिप फाइल में कर देंगे
No,
सर,
no,
जिप फाइल
no.
बना के।
चलो ठीक है कर दो लेकिन
तो
एक नोटबुक होए तो ज़्यादा बेटर रहेगा यार हम लोगों को चेकिंग करने में आसानी रहेगी
तो फिर ऐसे कर दें कि हाँ। ओके सर,
so
ओके
so if you are reusing a variable somewhere why don't you in so let us say you want to
सर, ओके
use
ओके सर, ओके सर। आई
let
गॉट योर
me
पॉइंट।
no you got my point maybe others did not let me help them if anybody has an issue so let us say you want to use a variable x at 4 different locations okay 4 different situations so in first part you can say x1 is equal to x you can start from this point okay then the second part you will have x2 is equal to x is that all right so if x1 is changing then it will not affect the change means the x okay then you can use the same x again and again okay so do not use the the what you can say primary and secondary variables you can call it so this is a primary variable which is being used again and again in the 4 different parts so do not use this okay make a copy of this variable before you use it okay is that all right Yashwardhan
Yes sir, yes sir.
Okay. Anybody else? Okay. Exam, the schedule has been announced or not yet?
No, sir. Schedule has not been announced. But
But
वही
the exam start from next Monday.
20 to 23 dates दिए हैं sir.
What is the 20 date? 20 is Monday.
Monday sir. 20. हाँ
Yeah.
Monday.
Okay. Monday to
Yes.
Thursday. And then when is the midterm break?
24th to 26th.
So matlab next week there are no classes. That's all.
हाँ yes sir.
Okay. So there is no midterm break. Only one day holiday.
Yes sir. Saturday
They,
Sunday है.
yeah, they are just making you feel good. Come on, they should not call that as a midterm break. They should have maybe called it as a Friday holiday. That's all not working. I don't know. Anyway, so let us talk about something which is bias variance trade-off. Okay, so let us see what this is. So the expected value of y0 minus your, so y0 is your what is y0? क्या है y0? y0 is your actual value. Okay, f hat x0 is your estimated value. Okay, so this is your so this is some residual square of the residual. Okay, so what is the expected value of this equal to? This can be divided into two parts, which is the bias, the variance of x0 fx0 plus the bias f hat x0 square plus finally the variance of your irreducible error. So this epsilon is your irreducible error. So the expected value of your sum of squares, okay, the expected value of sum of squares can be divided into these three components. Okay, the variance of your whatever estimation function that you're using, then the bias squared of that function plus the variance of the irreducible error. Okay, again we'll not go into some. Vaishnavi, you asked me the question about 1 over n minus k in the last class.
Yes, sir.
Yeah, the proof is quite long, so let us skip that. Okay, if you want, I'll send you a PDF of the proof. Okay.
Okay, sir.
So we'll again not go into the proof of this, but let us say that the smart statisticians have come up with this division of your this expected value of sum of squares, which comes out to be something like this. Okay, so what the main point is that if you want to reduce this, if you want to reduce the sum of squares, what do you need to do? You need to reduce both what? Variance and bias. Okay, you need to this cannot be reduced. Okay, the irreducible error is there because of various things that we have previously talked about. We can do nothing about it. We can only change these two. Okay, so both of them should be small for us to have a small expected value of the sum of squares or the sum or the residual sum. Okay, so what is variance? How do you define variance? Any idea? What is variance? In this particular case, when we're talking about variance of this function,
सर इन जनरल तो वेरिएंस वो होता है कि कितना स्प्रेड आउट है डेटा, मतलब
Yeah,
actual-
but in this case we are talking about a specific function. Okay, so how do we define that? Means the a layman's definition of variance in this particular case would be how much f(x) this function changes based if you change your data set. Okay. Okay, we've already seen this previously. Okay, so if you remember, we have done in your programming assignment, you have seen okay, if you had what if you had a, a 4-dimension a 4-level polynomial. Okay, we fit a 4-degree polynomial to our data set. So we had a data set like this. Okay, we had 40 different points. Okay, and we fit 4-degree polynomial to the first 5 points, and we fit that to the last 5 points. What did you observe? What did you observe in that case? क्या हुआ था?
काफी डिफरेंस था.
काफी difference आया था. Okay, whereas in case of a single degree polynomial, what did you observe?
It was almost same.
The difference was not that significant. Okay, so we can say that the 4-degree polynomial had a higher variance as compared to a 1-degree polynomial. Okay, so if we are talking about fitting polynomial functions, a higher degree polynomial, something which has more degrees of freedom, has higher variance as compared to something which has less degrees of freedom. Okay, so that is one thing. What about bias? Bias क्या होगा? It is opposite of variance in one sense. How much your function does not change. Okay, even if you change your data. Okay, how much your function does not change even if you change your data. So what happens in that case? Let us say I choose a function like this. Okay, let us say my function looks something like this. Okay, y some y1 or some I don't know what to call this. Okay, y prime. Okay, let us call this as y prime. Okay, so if your function stays the same value y prime throughout, irrespective of the value of x. Okay, so this is y and this is x. Irrespective of the value of x, what can you say about that particular? So will this, if I fix this at y prime, okay, what is going to happen if I change my data set? If I change my data set,
It remains same.
it will remain the same. Okay, when you move from one data set to the next data set, out this will stay the same. It does not really matter what this is. And even let us say, let me change this to what about if I had a line? Okay, compared to this flat thing, okay, a flat plot, a constant value of y. What is this? Do you think this has more variance or less variance, or more bias or less bias as compared to this?
So less by
Less bias.
Less bias. In this case, we are fully biased. Okay, we are saying that it is fixed at a certain value. Okay, so we are introducing a lot of our, so it actually comes from your English word bias. Bias means that you are predisposed towards something. In this case, we are predisposed towards this function, the output being a constant value. Okay, but in this case, what do we have? Let us say this is y is equal to mx plus c, or call it as fx. F at x is equal to mx plus c. So in this case, what do we have? We have freedom of choosing a different value of m and different value of c. Okay, so compared to this, what is going to happen if you change your data set compared to this one? In this case, this stays fixed at this particular value. Okay, in this case, what is going to happen if you change your data set? What is going to happen to your fx? Will it change?
Yes, sir.
compared to this.
Yes, sir.
It will change more compared to this. So this has less bias. Okay. So this has the most bias, this has a little less bias. What about if you move further and further higher in degrees? We are reducing our bias, but we are increasing our variance. Okay. So now the question becomes, how do we balance these two? How do we balance bias and variance? Okay. So for example, in this particular case, why should we choose a linear model and not a 4-degree polynomial? Okay, how do we decide that? That which would be the best way of fitting this data? So if I were to plot, let me erase this one and draw a different plot. So this is your degree of polynomial, okay, and this is your variance and bias. I am plotting both variance and bias over here, okay. I'll use the orange one. So as you increase the degree of polynomial, what happens to your variance? क्या होता है? As you increase the degree of polynomial, what happens to your variance?
Increases.
So your variance. So I'm going to write in the orange, draw in orange. So as you increase your degree of polynomial, your variance is going to increase. Okay, and it will keep on increasing. There is nothing that is going to stop your variance. What about bias? What is going to happen to bias as you increase the degree of polynomial?
Decrease.
It will decrease. Okay, so as you increase the degree of polynomial, your bias is going to decrease. Okay. So bias is in blue color. Can you see the blue color? Purple? Can you see that or no? Can you distinguish the color or no?
We can distinguish blue and orange.
Okay, that's fine. So what are we interested in? What is the thing that we are interested in? We are interested in this. We are trying to minimize our mean squared error. And what is it dependent on? It is dependent on variance plus bias squared. Variance is obviously a positive quantity. Okay, maybe you can go and look at the definition. The variance is always a positive quantity. Bias is not a positive quantity, not necessarily a positive quantity, but when you square it, it's going to become a positive quantity. So when you are adding two positive quantities and you want to minimize it, so you want to minimize the sum of those two quantities. So what do? At which point do you think you will have a minimum? Somewhere here?
Intersection.
Maybe the intersection, but not necessarily.
Yes.
Depends on how fast each of these two is increasing, but means we have to, again, the point is that we have to balance both of these things. Okay, so the sum of variance and bias is going to look something like this, so this is going to be the sum of variance and bias squared. Okay, let's call this as bias squared. Okay, instead of just calling it as bias, let us call this as bias squared. Okay, any questions, anybody? So the main point is that whenever you're choosing a model, you have to choose a model in such a manner that both of these we select an optimum value of the degrees of freedom that you have in your system, so that your variance and bias both are reasonably small. Okay, none of them is too high, has a too high a value. Now let me ask you, how do you choose this degree of polynomial when you're trying to fit this? क्या करेंगे हम?
यही देखेंगे जहाँ सबसे कम है ये
वो तो हम statisticians या theoreticians, obviously आसान है ये plot बनाना, लेकिन in reality it's not that straightforward to calculate these things, no? हम क्या करेंगे? तो
मतलब सर इस प्लॉट का तो काम वही है ना कि डिग्री पता चले हमें।
हाँ, लेकिन ये प्लॉट बनाना इतना आसान नहीं है ना, मैंने बना दिया।
यस सर।
एग्जैक्ट फॉर अ स्पेसिफिक प्रॉब्लम कैलकुलेटिंग दीज थिंग्स इज नॉट दैट ट्रिवियल. सो व्हाट डू वी डू? क्या करना चाहिए? आशा, व्हाट डू यू थिंक?
हिट एंड ट्राई।
Yeah, that's what we are going to do anyway. Asha, you there?
Yes, sir.
What do you think we should do?
I think hit and trial is the best thing here.
Anyway, I think we come up with a lot of theories, but finally, uh, as I told you in last year in semiconductors, we finally it all boils down to your fitting parameter, which nobody has any idea where it came from. Okay, so that's what we do here also. So, so as I let me erase these and let me move to a slightly different topic, which is related to this, but also not related, because that is a universal sort of. So if you have your data set, okay, this is your data set, okay. So now how do you find out the accuracy of your data set, means of your model? कैसे पता करोगे? This is the only data set that you have, okay, पूरा data तुम्हारे पास यही है अभी, ठीक है? How do you find out the accuracy of your model? क्या करोगे?
तो डिवाइड कर दे ट्रेनिंग सेट और टेस्ट सेट में.
Yeah, Yashwardhan, you said that, and what did Dipanshu say?
Sir, I said we can split up the data into test and training purpose.
Yeah, so this is the data set that is available to you, so you can divide this into two parts. Okay, usually we want maximum data for training. Okay, we want because data is power in today's world, and in machine learning also. It's primarily the more data that you have, the more likely that your model is going to be able to predict various different situations. Okay, so you want as much data as possible, but you also do not want your test data to be so small that you are not able to with high degree of confidence say that your test means your model was quite accurate. So what we usually do, maybe divide this into maybe 70-30. Okay, 70% of your data goes into training. Okay, and once you have during training, what do you use? You use the input as well as the output. ठीक है, ये इसमें x के columns होंगे और y के columns होंगे. Okay, you have that x and y everywhere. Now what about when you are doing testing? हम क्या कर रहे हैं? टेस्ट में क्या करेंगे हम? So this is going to give me a model. Okay, using training we'll get a model. Okay, and this x will go as the input to this model. Okay, and which will spit out an estimated value of, for some particular value of x0, it is going to give you an estimated value of the output. Okay, you're going to compare this to your actual value. Okay, you are going to compare these two and say whether they are close enough, then we say that this is good, otherwise this is bad. So we want, that is how we find out the accuracy of our model. Okay, obviously, what do you think is wrong in this methodology? Any idea?
They are using same data for
Means it is
testing
sort
as
of the same data, same methodology was used, same everything was done, but in real world this is not going to be the case. So obviously your you can think of this as the best case scenario. Okay, because whatever biases, okay, the humanly biases were present in collecting this particular data set are also present in collecting this data set. Okay, so obviously when you go into the real world, this model is going to perform worse than the test accuracy that you might get. Okay, so you can think of this as the best case scenario, best case test data set that you can possibly have. Okay, the real world performance is obviously going to be worse than that. Now, can we use something like this for finding out the best degree polynomial that you should use? ऐसा कुछ और कर सकते हैं हम? So here we divided our data set into two parts, the training data set and your test data set. Can we do something similar to figure out the 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 degree of freedom that your model should have. What is our end goal? हमारा end goal क्या है? What is our end goal? Is to make good predictions.
Yes.
ठीक है ना? That is our end goal. So anything that we do should be to help us in making those good predictions. Okay, we really do not care about almost anything else, okay, except making good predictions. So what should I do so that I can make a good prediction using this particular? What degree of freedom should I allow my system to have? क्या कर सकते हैं हम? मेधा, any idea?
एक एक करके सारे चेक कर सकते हैं
हाँ?
तो सारे मॉडल्स ट्राई कर सकते हैं, जिसका बेस्ट फिट आएगा उसको एक्सेप्ट करेंगे.
Okay, that is a good thing. So Medha is saying, let us say that let us call the degrees of freedom as D. Okay, so D is your degrees of freedom. Okay, D is your degrees of freedom. So what Medha is saying that let us start with D is equal to 0. Okay, then do this whole procedure, compare these two. ठीक है, हमने ये सारा सब कुछ किया, इसकी टेस्ट एक्यूरेसी निकाल ली. Okay, we found out that at D is equal to 0, my test accuracy was, let us say, 50%. Okay, D is equal to, फिर मैंने next क्या किया? I chose D is equal to 1 and then find out the test accuracy again. ठीक है, कितनी आई? Let us say it improved. Maybe it became 80%. Okay, and you keep on going. D is equal to 10. Your test accuracy was, let us say, 83%. Okay, and maybe 10 is a reasonable number. We stop there. Okay, and again we go back to, so go back again and again to Occam's razor. What did Occam say? What did Occam say? The philosopher
Easy.
Occam.
Easy is the best.
The simplest is the best model usually. Okay, so since we see, let us say D is equal to 2 is 81% and so on and so forth, you see that between D is equal to 1 and D is equal to 10, what is happening? What is happening in this case? क्या हो रहा है? Accuracy improve हो रही है, लेकिन कोई इतना significant change नहीं आ रहा है. तो हम क्या कह सकते हैं? So this is most likely what is happening here. Most likely what is happening in this case. हम इसकी बात कर चुके हैं थोड़ी सी. What is happening in this case? When you see that, so you can sort of think that we are sort of reaching the plateau of this bias and variance curve. So what can you say in this particular case? क्या हो रहा है?
वही सर, वेरिएंस प्लस
कॉम्प्लेक्सिटी ज्यादा है पर फायदा कम है. तो
हाँ, so in most cases we might choose this one compared to this one. So this is possibly, so when we are using D is equal to 10, we are possibly overfitting. ठीक है, we are overfitting. हम बात कर चुके हैं ना इस टर्म की. Have we talked about this overfitting and underfitting?
Yes.
We have.
Yes.
Yeah. So we are possibly overfitting because the difference between the test accuracy of D is equal to 1 and D is equal to 10 is not that significant. Okay. It may be, but let us say for now, for argument's sake, that is not significant. So we are going to most likely going to choose this one. Okay. Let us say we have made a decision that we are going to choose this one. Now, can you tell me, is there some mistake in using this methodology for finding out your test error rate? So after doing this, I am saying that my test error is 20%. Okay. This is the accuracy. Accuracy is 1 minus error, or 100% minus the error. So error is going to be 20%. So I am saying the 20% error I have. So do you think that there is some mistake in this methodology? Anybody? इसमें क्या क्या गलती है? मैं बता रहा हूँ गलती है. क्या गलती है?
So we are not going beyond 10, D10 and
No,
it
no,
may
no.
be.
No. We can go to 100. Still this is wrong. Doing it this way to find out the accuracy.
तो मतलब d इक्वल्स टू 0 से हर बार स्टार्ट करना मतलब थोड़ा सा ज्यादा वर्क है ऐसा कुछ।
नहीं वो बात नहीं, फिलोसॉफिकली गलत है। लेट अस फॉरगेट अबाउट कंप्यूटेशन पार्ट, फिलोसॉफिकली की गलत है। फाइनली हम सारी फिलोसफी को भूल जाते हैं, हम फाइनली कहते हैं कि भाई जो डेटा है वो सही है, लेकिन तो भी हम बात कर लेते हैं कि फिलोसॉफिकली क्यों गलत है। टू कैलकुलेट योर टेस्ट एरर यूजिंग दिस मेथडोलॉजी, व्हाई डू यू थिंक इट इज रॉन्ग?
रियल लाइफ डेटा पे अप्लाई नहीं कर रहे हम, मतलब एक पर्टिकुलर डेटा सेट पे बस।
So if you look at this, what is happening? Your test data is participating in what?
टेस्ट एक्यूरेसी।
Is participating in the creation of the model. Okay, isn't it? Your test data is participating in the creation of the model. This is the process of creation of the model. Okay, and test data is participating in that, and we are using that to determine, to say that what is the accuracy of something. Do you understand? It is not an independent data set. Okay, usually test data set should be completely independent, which has not participated at all in the whole creation of the model part. Okay, here we are creating the model, and during that creation phase itself this test data was participating. Okay, so there is very high likelihood that we have means we have trained our model to fit this particular test data set. ठीक है ना? इस पर्टिकुलर डेटा सेट में तो हमारी ये बेस्ट एक्यूरेसी आ रही है इतने पे, लेकिन पॉसिबल है कि इन अनदर डेटा सेट दैट यू माइट नॉट गेट द बेस्ट एक्यूरेसी फॉर दिस पर्टिकुलर d is equal to 1, you may get it for something else.
सर
Okay.
बट हमने कहाँ टेस्ट डेटा सेट को इसके लिए यूज किया? वो तो अलग डेटा सेट था ना जिससे हमने d0 d1 किया कैलकुलेट।
नहीं तो इसी से तो कर रहे हैं हम, बार बार इसी पे तो चला रहे हैं हम। d is equal to 0 चूज किया, इसको ट्रेनिंग माना, इसको टेस्ट माना और एक्यूरेसी निकाली। फिर हमने d is equal to 1 चूज किया, इसको ट्रेनिंग माना, इसको टेस्ट माना, फिर हमने एक्यूरेसी निकाली।
यस सर।
डू यू अंडरस्टैंड?
यस सर।
So your model is fitting, your model is accurate for this particular data set. Okay, but it may not be. So this test participated in the creation of this model. Okay, we do not want that to happen. So what do? We divide our whole data set into 3 parts instead of 2. Okay. So what are the 3 parts? So this is your data set. You have your training, and this is the second component is called as the cross validation set. Cross validation set. Okay, and the final set is your test data set. Okay, training set, cross validation set, and test set. Okay, so many times you will also see CV. Okay, CV stands for cross validation. So usual division of these 3 sets from the whole data set is 60% goes to training, 20% goes to cross validation, and 20% goes to test. Okay, that is the usual division that people use. Now what are we going to do? Anything that participates in the creation of the model, but you have to do some kind of testing. Okay, like here we are doing some kind of testing to come up with the best value of d. Okay, degrees of freedom. Okay, so what are we going to do in this particular case? How are we going to calculate all these? Test accuracy. So we are not going to calculate the test accuracy, we are going to calculate the cross validation accuracy. Okay, this test set is not going to participate in the creation of the model at all. Okay, it will not participate in the process of creation of the model at all completely. Okay, this only becomes visible to your model once your model has been created. You only use this at the last step of finding out the real accuracy of your system. Okay, otherwise you don't show this data at all.
इसमें भी एक डाउट है,
हाँ.
डेटा सेट तो हम सेम ही यूज कर रहे हैं, तो जिससे वो ट्रेन हुआ है, मतलब जो कॉन्सेप्ट हम पहले लगा रहे थे कि उसी को हम ट्रेन कर रहे हैं, उसी से हम टेस्ट कर रहे हैं, तो क्रॉस वैलिडेशन भी हम उसी डेटा से कर रहे हैं और बाद में टेस्टिंग भी उसी डेटा से कर रहे हैं।
उसी डेटा से कहाँ कर रहे हैं? 20% डिफरेंट है ना वो।
नहीं, एक ही टाइम में
मतलब वो जो
जो
ओरिजिनल फिलोसॉफिकल प्रॉब्लम है उसको तो सॉल्व कर ही नहीं सकते ना, मतलब वो हमारे हाथ में है ही नहीं। नहीं आया समझ में?
प्रैक्टिकल अप्रोच तो ये होती है ना कि हमने अपना मॉडल बनाया और फिर हम कोई इंडिपेंडेंट डेटा सेट जो हमने कभी यूज ही नहीं किया वो दोबारा कहीं
हाँ
से
तो यूज
जनरेट।
कहाँ हो रहा है ये? नहीं कहाँ यूज हुआ?
नहीं, मैं मतलब ये कह रही हूँ कि जैसे हमने जब हमने अपना डेटा सेट एक्वायर किया, तो
हाँ
वो जो डेटा सेट हमने लिया है वो हमने एक ही मेथड से किसी ने जनरेट किया होगा, हमने वहां से उठाया है,
तो
मतलब
वो
उसमें वही।
नहीं तो उसको सॉल्व कर ही नहीं सकते ना, वो तो एक फिलोसफिकल और बड़ी फिलोसफिकल प्रॉब्लम हो गई वो तो। उसको तो सॉल्व करना पॉसिबल, एक सेंस में पॉसिबल ही नहीं है।
मतलब जो पिछला वाला था 70-30 वाला, उसमें
हाँ
भी अगर हम वो टेस्ट 30% वो यूज ही नहीं करते तो क्या दिक्कत आती?
नहीं यूज़ नहीं करते तो ये कैसे आता? एक्यूरेसी कैसे निकालते हम? जो हमने एक्यूरेसी निकाली थी डी इक्वल टू 0 पे, डी इक्वल टू 1 पे, वो कैसे निकालते?
अ, तो सर जैसे अभी निकाल रहे हैं टेस्ट पे।
अब तो दूसरे तरीके से कर रहे हैं ना हम क्रॉस वैलिडेशन से निकाल रहे हैं एक्यूरेसी। ठीक है, इस डेटा सेट से एक्यूरेसी निकाली हमने और हमें पता चला कि दिस इज द बेस्ट। ओके, लेट अस से दैट दिस कम्स आउट डी इक्वल टू 10 इज 75%।
सर बट जब हम टेस्ट कर रहे हैं तब हम ट्रेन, मतलब आप कह रहे हैं कि जब 30% लास्ट टाइम टेस्ट करे थे तो वो साथ साथ ट्रेन भी हो रहा है उसके अकॉर्डिंग।
हाँ मतलब वो क्योंकि वो उस प्रोसेस में पार्टिसिपेट कर रहा है ना वो डेटा सेट। जो टेस्ट डेटा सेट था हमारा, तुम्हारा प्रोसेस में पार्टिसिपेट कर रहा है ना वो, कि डी इक्वल टू 1 पे हमारी बेस्ट एक्यूरेसी आ रही है। वो बता रहा है ना, वो डेटा सेट तो बता रहा है, तो वो सॉर्ट ऑफ हमारा जो मॉडल है वो उसको फिट करने की कोशिश कर रहा है उस डेटा को। नहीं आया समझ में? हम इस पार्ट, इन दिस पार्ट ऑफ द प्रोसेस व्हाट आर वी ट्राइंग टू डू? We are trying to find the best value of D so that my data set, the test data set fits this best. ठीक है ना?
सब वो समझ में आ गया, बट मतलब टेस्ट केस तब भी तो इसी क्योंकि हम एक ही डेटा सेट क्रॉस वैलिडेशन के लिए यूज कर रहे हैं, फिर उसी डेटा सेट का एक पार्ट हम टेस्टिंग के लिए यूज कर रहे हैं,
उस
तो
डेटा सेट
मोस्ट।
का पार्ट नहीं कर रहे हैं ना यार। मैंने वो बात बोली थी, अब उसको भूल जाओ ना, बहुत हो गया वो। क्योंकि वो हमारे सॉल्व करने के मतलब सारी मशीन लर्निंग सिस्टम्स जो है वो इसी तरीके से होती हैं। तुम्हारा 100% डेटा सेट होता है एंड यू डिवाइड दैट इनटू 2 पार्ट्स। Okay, let us forget about cross validation for now, your training part and your test part. Obviously the overall bias of the data collection is obviously there, you cannot get rid of that. That is, you can think of that as your irreducible error. ठीक है ना? So please understand, let me ask you. So we are using in this particular case we are using your training data set to train all of these, okay, and cross validation to find out the accuracy of all of these. Has this particular model seen this 20% data mera? That is the point.
नॉट
Okay,
Sir, so basically we want the accuracy of cross validation part and test should be same.
no, it should
Right.
not be the same. That is not the point. The point is, using this cross validation we are finding out the best degree of freedom to use. Okay, we find
like
out.
sir, what I want to say, अगर टेस्ट, अगर क्रॉस वैलिडेशन में कुछ एक्यूरेसी आई और टेस्ट में वो एक्यूरेसी फेल हो रही है, तो फिर हम फिर से डिग्री चेंज करना कंसिडर करेंगे ना सर?
नहीं 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 नहीं, फिर तो गलत हो जाएगा। फिर से वो टेस्ट पार्टिसिपेट करने लग गया
हाँ
एक
सर,
बार।
वही
आया समझ में? फिर हम ऐसा नहीं करेंगे। मतलब थोड़ा कॉम्प्लेक्स है कि फिर उसके बाद क्या कर सकते हैं हम, बट वंस योर मॉडल हैज सीन दिस टेस्ट डेटा सेट, यू कैन नो लॉन्गर यूज इट एज अ टेस्ट डेटा सेट. Okay, please understand that you might have to create more data if you want to do something what you are suggesting right now, Dipanshu. Okay, it can no longer be used as an independent test data set, which is what it should be if you really want to test the accuracy of a model. Dipanshu, is that okay? Once you have seen this data set, this cannot be used to refine it. If it is used to refine it, then this is no longer a test. This becomes part of cross validation. Then you have to create a new test data, get it from somewhere. ठीक है?
अगर रिफाइनिंग के लिए यूज ही नहीं हो रहा तो फिर मतलब टेस्ट ही क्यों कर रहे हैं? मतलब टेस्ट
हाँ,
करने का क्या पर्पस क्या है?
टेस्ट करने का क्या पर्पस है? मतलब योर मॉडल शुड बी गुड इनफ सो दैट इट हैज गुड एक्यूरेसी फॉर अ गिवन फॉर एन अननोन डेटा. दैट्स ऑल. सो दिस इज एन अननोन डेटा फॉर इट.
यस सर.
प्रीवियसली अनसीन डेटा.
सर बेसिकली हम एक्यूरेसी फाइंड कर रहे हैं ना टेस्ट के साथ भी.
हाँ, होल्ड ऑन अ मिनट, आई विल कम बैक. Yes, Dipanshu, tell me what you were saying. Can you repeat?
Yes, sir. Sir, I was saying like, sir, assuming if we have unlimited data set, okay,
Yeah.
sir. Sir, and like if a client asked us to make a model, say with 90% accuracy, and if after training and cross validation we achieve that accuracy, but in the test we failed, so सर हमारा टेस्ट डेटा जो है फिर वो ट्रेनिंग में ही काउंट होगा, राइट सर? एंड वी विल टेक मोर डेटा टू टेस्ट अगेन बाय चेंजिंग आवर मॉडल.
So once you have shown your data to your model, okay, once it has been shown, and based on that feedback, you are trying to make some changes to your model, you can no longer use it as test. Okay. So
Yes,
so
sir.
so your 90% should be on cross validation, no, sorry, on test, not on cross validation. Once this data has been shown and you have shown to this model and you are making some changes based on this test data set, it is no longer test data, it becomes part of your cross validation data set. Okay,
Yes,
you have to
I
create,
get
you have
it.
to get new data for doing test, which has been previously unseen, and your model has not been changed based on that feedback. Okay, any feedback that has been provided should be part of your cross validation. Only cross validation can provide a feedback. Test data set should not provide any feedback. ठीक है?
Yes, sir, I get it.
Any other questions? So इस केस में हम क्या करेंगे? We'll do what? We'll try to figure out at which particular degree of freedom you get your best cross validation accuracy, and you will use that particular model to do your test, and that will be the accuracy of the model. Okay? Any questions? Anybody else? नहीं? चलो ठीक है, बस यहीं पर रुकते हैं फिर. If anybody has a question in the assignment, I'll answer that. Otherwise, we'll stop because the assignment has not been submitted yet. If you want, yeah.
क्रॉस वैलिडेशन एक तरीके से वही है कि हम बेसिकली टेस्ट डाटा से ही इनपुट ले रहे हैं कि ये खराब है, फिर उसी पे टेस्ट कर रहे हैं.
Yeah, we have no good way of so what you are saying, hit and trial. So this is a systematic way of hit and trial. Okay, and we are giving a fancy name to it called cross validation. Okay.
मतलब पहले हम जो क्वेश्चन गलत हो रहा था उसी को फिर से हम ट्राई कर रहे हैं कि उसी को कैसे भी सही करो, और उसी को फिर एक्यूरेसी में ला रहे थे, बट हमने बोला कि अब फ्रेश रखते हैं जिसपे हमें टेस्ट करना है.
हाँ हाँ. So this participates in the process, क्योंकि इस पे तो हमें पता ही है कि 80% एक्यूरेसी आएगी, तो उसमें फिर कुछ बचा नहीं ना. फिर हम एक नया डेटा सेट, एक अनसीन डेटा सेट लगा के देखते हैं, एंड वी सी दैट दिस शुड बी क्लोज इनफ टू दिस एक्यूरेसी. Okay, if it is not, then obviously we have some error somewhere. Okay.
Yes, got it.
Anybody else?
सर प्रैक्टिकली भी मतलब जब रियल लाइफ में अप्लाई करते हैं तो सर उस टाइम भी ये डिग्री ऑफ फ्रीडम निकालते हैं, या सर ऐसा होता है कि मतलब एक टेस्ट डेटा पे एक थ्रेशोल्ड के बाद कोई दूसरा डिग्री ऑफ फ्रीडम अप्लाई होता है? सर ऐसा कुछ करते हैं क्या कि एक ही डिग्री ऑफ फ्रीडम को पूरे डेटा सेट पे अप्लाई करने का ट्राई करते हैं?
नहीं, हम पूरे डेटा सेट से एक मॉडल बनाने की कोशिश कर रहे हैं, उस मॉडल का डिग्री ऑफ फ्रीडम निकाल रहे हैं हम.
हाँ,
तो अलग अलग कैसे होगा?
हाँ सर, मैं मतलब प्रैक्टिकल में पूछ रहा हूँ कि सर जैसे कि हो सकता है कि एक थ्रेशोल्ड के बाद कोई दूसरा मॉडल वहाँ पे बढ़िया से फिट हो, एक्स स्क्वायर फिट हो, और 0 से लेकर किसी x0 तक y इक्वल्स टू x, मतलब डिग्री 1 की सर फिटिंग अच्छी हो और फिर उसके बाद 2 डिग्री की फिटिंग ज़्यादा अच्छी हो, तो सर ऐसा कुछ करते हैं क्या?
So what you are saying, let us say that you have an XY data set which looks something like this. Let us say it looks something like this.
Yes.
Okay, and so you are saying piecewise sort of. So in this region, linear is a good fit, and in this region, parabolic is a good fit. That's what you are asking.
Yes, sir.
So your model should be able to predict both of these. Okay, at once in one model, not necessarily one equation, but the one model. Okay.
तो सर एक मॉडल होगा तो मतलब फिर एक ही फंक्शन होगा, तो सर कोई मतलब ऐसा फंक्शन तो होगा नहीं कि जिसका शेप ऐसा हो. और
हाँ, so polynomial might not be a good approximation for this. You might have to do a different approximation.
Okay, sir.
Okay. So there are many assumptions that we are making. Okay, when we are trying to fit something, obviously that assumption might not be a good assumption. Okay.
Sir.
Anybody else? So in this case, degree of freedom or the degree of the polynomial, or in this case polynomial, is what is called as a hyperparameter. It is a hyperparameter. It is not directly coming from the model. Okay. For example, when we are talking about your model fx is equal to w0 plus w1x. Okay. When you are doing the fitting, you are directly getting the values of w0 and w1. Okay. But in this case, what do you have? The degrees of freedom we have chosen here 1. Okay. That is an obviously not necessarily true in many cases, that your degree one is going to fit. So when you're trying to find the degree of polynomial, it is not directly coming as a result of doing this fitting of the model which we did in your assignment. Okay, it is coming from a different method which we are doing here, which is applying a sort of a hit and trial, okay, and using cross validation data set. Okay, so such parameters which do not directly come out as a result of fitting your data, fitting your test and training data, are called as hyperparameters. Okay, these are your parameters. W0 and W1 are your parameters, and these are hyperparameters which are outside, in one sense, the scope of fitting of your model. Okay, but we fit them somehow by using such an approach. Okay, so these parameters are called as hyperparameters. Okay, in case of polynomial fit, one hyperparameter might be your degree of polynomial. Okay, okay, that is all I have for today. We'll continue on Wednesday. Bye bye. Any questions? Oh, okay.